Now the final talk today, for the day one, we can say the bonus talk, as it wasn't planned initially. So in a second, you will listen to adapter design pattern, how to work with third-party dependencies. And this talk is prepared by Michał Mynarski, who is an iOS engineer working at Ulam Labs and Mobile Vikings. And he is also, could I say, a fan of podcasts and recording them? Yeah. Okay, so please give him warm welcome. Michał Mynarski.
One, two.
Może spróbujmy jednak z mikrofonem, okay?
Hi, nice to meet you. Nice to have you all here. Before we go, I have a little announcement from organizers that we have after party and Podróż Beach Bar, and all the information you need are on the Twitter account. I let myself start this after party a little bit earlier. So presentation which I'm going to show you right now was created by Krzysiek Rodak from BlockFi and me, but he can't be here tonight, so he asked me to present it. Fortunately, we use the same design patterns, so I hope it will be easy for me. So today we are going to talk about relationships. It makes sense at some point, I promise you. You know, when you have this good relationship, loving one, when everything works smoothly and it's just perfect. It's like two well-written classes in your code base working together, something beautiful. But sometimes we need to struggle a little with relationship which we care about, but the communication is just not so smooth. And at the core of every problem in a relationship is communication problems. So when we fix communication, maybe all other things will come cleaner in the future. So, okay, enough. Let's talk about the real problem. The real problem we have is the how to use third-party dependency without all these properties, this specific stuff which we mostly don't use, but it's required to be there, scattering all our code base. And I'm not here to talk about the big utility libraries like Alamofire. No, we're going to talk about like analytics one, the one we can't really develop in-house, but we really need them, like payment providers or live chat, who knows. So what's the problem with them? First and the most, their use cases are changing, and they are often changing due to our changes in business requirements. Also, they use unnecessary functions, unnecessary parameters in function signatures. Their setup code is accessible from every part of the app if we don't encapsulate it, and we don't want it. They also don't fit well in our architecture or don't fit at all. And most importantly, their interfaces are changing from one version to another, which makes really big headache every time we update. You know this feeling when you update your pods or something and then you have like 50 errors? At the end of this presentation, I will make them 10. Yeah, and they are untestable, which is really hard to stand. So, okay, what we can do about it? Firstly, we can limit their usage, but as we said before, we don't really can get rid of them entirely. So we can try to limit their impact on our code base by separating them a little. But how, Michael? Okay, how? Well, we can, for example, use one of the widely used and well-known design pattern, and then we can look which one is solid compliant. And in this case, we can look for the one which is compliant with the single responsibility and the open close, because these ones are the most important in this case. And the most important thing about this solution is we don't want only to wrap our library, we want to make it compliant with our good quality code, because that makes them testable and that makes them good to work with. So what structural design patterns do we have? We have facade, we have proxy, decorator, bridge, and adapter. Is anybody here who know all of them? Good, because we're going to talk about every one of them. So which one should we use? Let's see the facade. Facade is really nice, but it only provides us simpler interface, but it intends not it's to change the behavior inside. The proxy, on the other hand, will not provide us the same interface, and it can be conditional initialized, which not exactly what we need. Then we go to decorator, which, as the name says itself, decorates our library, but we want to limit its usage and limit its capabilities to fit in our use cases. And the last one is bridge, which basically make one bridge one interface for several implementations, excuse me. So this brings us to the natural conclusion, which is adapter. And adapter is really great because we can create interface which is compatible with our code base. We can wrap and encapsulate all the specific parameters from the library inside our adapter. We can remove direct calls to the library. We can split the monolith interfaces, which have a lot of different functions from different use cases, and we can split them into separate interfaces per use case and then use composition to make it work. And in the case of major changes in the interface, all the changes that we need to do are limited to the adapter and its dependencies instead of a lot of source files in our code base. Okay, so how it works. We have adaptee, which is basically our library, and we have declared interface, which have simplified methods of the library, and then in the body of the declared method, we have the call to the adaptee itself, to the library itself. Working example. So this is example of Brace. It's, I think, pretty popular dependency. And this is starting function, which is static, which makes it pretty hard to unit test. And then it has it all with AppBoy options, which are AppBoy specific stuff. So AppBoy is pretty much the same as Brace. They just like switch names. And we have also app delegate parameters, which are application and launching options. So we have multiple sources of parameters, which is also not good. So what are we going to do about it? Well, we encapsulate the starting process into protocol. Let's call it starting. And this protocol, we have one function, and we'll have all the same signature that the one from the library. So we can extend the library by conforming to our protocol without any problem. And then we will take care of the starting process itself. And we create a protocol which will have also start function, but this one will be simplified. We strip down the AppBoy thing because this is the other source of the truth. And we can, okay, so what about these AppBoy options? We can contain them, we can encapsulate them into protocol, let's call it containing. And this protocol will have two properties that are needed to start the app. And whatever the source of configuration our app is it, for example, property list or some kind of wrapper over property list, whatever we have configuration, let's make it conforming to this protocol, so it will just give us the needed parameters. Great. So let's talk about the starting process itself. Let's make an adapter which will handle that. And this adapter will have interface which will implement the starting function, but the one without the options from AppBoy. And let's have our adapter to have adaptee. And since we know that Brace or AppBoy is conforming to our brace starting type, we can inject it here, and we can inject the container. So we have all the things that we need to start an actual library. So this looks like this is like the body of the function. So in the body of the function, we just use the container, and we use adaptee to call the starting of the library. And how we should use it? Well, we go to the app delegate where we should start this library. And thanks to this little encapsulation, we just call start with the parameters that are in the app delegate. What benefits are of these solutions? Well, we decoupled between app delegate and the configuration. The app-boy options were not needed in app delegate, so we can just separate them. We simplified interface of the start function. We have immunity in any changes in the start function signature that could be done in the future. And we don't have to import brace into app delegate, because the one thing we all hate is opening app delegate and have 20 imports of different libraries. And what's most important, right now we can test it. Even though we can test it app delegate itself, we can test the starting function and our integration. And since we are talking about testing, let's see how this works. This is manually like caveman. Write in mock. We don't use this here. I know everybody use Sorcery, right? So we have this little mock of starting process, and it has all the properties which are static because the start method is static. We have counter, we have cold flag, we have all the passing parameters, and yeah, and how the test should look like. This is like setup and teardown. Nothing big. We have mock of the starting protocol, and this is very nice part because we can inject this mock in the unit test, not the library itself, and this allows us to test whole thing and all the use cases. And we should not forget that the starting function is static, so the parameters that it will saving in mocks are static too, which we need to handle in the teardown because test will be failing and we have some different behavior. So the test itself looks like this. We can test if the starting in the adapter calls the starting in the library, and we can ensure that it does only one time. And then we can test if the parameters passed to the adapter via configuration, and that they are the good parameters that are passed to the adaptee. More cases. Well, this was only the starting of the library. Of course, we want to do with our library different things. We want to, for example, set a user ID, track an event, and even though we can, for example, encapsulate the shared instance, if we had to struggle with it, we can just make provider adapter and create our own error. It pretty much looks the same. And then we have like setting user ID, which could be encapsulated in a different protocol, and we have separating them by use cases, which is pretty nice because all the different places in our app only use some part of our library. Not always it's the whole interface that our library gives us. So going to conclusion, what's the benefits? Well, we separate dependency-specific elements from the code base. So every changes will be limited to our adapter. And then we separate the use cases thanks to interface segregation and composition. Oops, sorry. We have immunity from changes if something changed in our app. In our library, all the changes are just encapsulated in our adapter. We have compatibility with solid principles, which is the very, very, very important one. Because if you have like big code base and you put a lot of effort into have it in quality coded manner, then you don't just want to use singletons of couple of libraries that are needed in your application, and that brings us to the testability and mockability. And every use case, thanks to it, could be tested. And even though at some point maybe you will need to switch from one analytics tracker to another, all you have to do is probably just change the way you implement the adaptee, not adapter itself. If you have any questions, this is the guy you should ask him. This is Krzysiek. I'm not going to do everything for him. Joking. Like big applause for the Krzysiek because he gave a great source material for me and it was a pleasure to work with. You can find us on Twitter, and there's some bibliography. And yes, I think we're good on time, yes?
Yes, we have a few minutes, so if you have any questions, then please raise your hand.
Everybody wants to go to party.
Yes, I think so too. Okay, so thank you, Michał.